All right, so progressing on through chapter 15. So far, we've mostly been looking at the fields from point charges and dipoles, which, while they do exist in the real world, we are often in our everyday lives interacting with macroscopically charged objects with the charge spread over the surface. So in the real world, and outside of a physics lab where you might deal with a singly charged particle, we're dealing with charges spread out over surfaces. And these could have different shapes. So what we're going to be doing in this chapter is we're going to be laying down how to sum the charge over different surfaces. And this is naturally going to lead to doing an integral. Okay, so looking at a uniformly charged rod. Now I'll just make a quick note that obviously those of you that are in the algebra-based class, I'm not going to expect you to integrate, but I do expect you to understand how the summation is set up. Then you can just jump directly to the solution. And of course, those of you in the calculus-based class, I do expect you to actually be able to do the integrals. All right, so we're going to be looking at different shapes, and we're going to be doing this in detail. So we're really going to spend a lot of time on this first one, this uniformly charged rod. This is particularly useful because a charged rod is basically a wire, which is a shape we're going to see a lot. All right, so to derive the expression for the electric field of a wire, we'll make it generic. And so we'll do a rod of length capital L with charge capital Q. And we're going to observe at the midpoint. All right, so let's use a little bit of intuition to think about what a field would look like. So let's say we had a negatively charged wire. So we have a negative charge. We would anticipate that we'll have an electric field pointing in towards it symmetrically around the wire. Let's see if we draw this symmetrically. There we go. So we would anticipate that it would look like this. So we would expect a symmetric field. Likewise, if we had a positively charged wire, we would expect a field radiating out and also symmetric. So if the rod has an evenly distributed field, we can logic through how we would sum the charges. So rod has evenly distributed field. So logic through charge summation. Okay, so the first step we would do is we'd cut the object into small, easy pieces that we can handle. Pieces we know how to calculate. Then we'll draw the electric field for one piece. Spell this correctly. So hint, use pieces you can calculate. And once, as we start to derive the equations for more and more different shapes, your arsenal of usable pieces is going to get bigger and bigger and bigger. 2, you're going to choose an easy origin and axes. I mean, it's true, you can make your life harder by choosing something exotic, but what's the point of that? So then we'll use what you know. To write an algebraic expression for the change of electric field from one piece. And then step 3, we're going to add them up.